Hello students, I am Laxman Singh Rawat, PGT Chemistry at CIS Dasua. Students, I hope you are enjoying this method of teaching learning that CIS Dasua has come up in this hours of crisis. CIS Dasua's e-learning is helping students to study at their home so that they do not lag behind due to this lockdown. Students, I hope you have seen the previous lectures. Now today also we'll continue with some basic concept of chemistry. Today we will discuss a very important concept of chemistry, that is the mole concept and molar mass. Student, mole concept is very important because many of the numericals are based on the mole concept. And if you can find out the interrelationship between the different quantities which are used in the mole concept, you will be able to solve the numerical easily. Please see the video very clearly and try to understand the different concepts which are used here. Now let us quickly recap what we had done in the previous lesson. We discussed about Dalton's atomic theory. Now I'll quickly discuss all the points of Dalton's atomic theory, then we'll start with the new topic of today. The first point is all elements are composed of tiny indivisible particles called atoms. That means all the substances, all the matter, they are made up of very tiny substance, and which was called as the atom. Now the atoms of same element are identical. Atoms of any one element are different from those of the other element. What does it mean? If we take any one of the element, then all the atoms of that element will be of same type. However, if we take any two elements, then their atoms will be different. They will not be same. Okay. Next, atoms of different element combine in simple whole number ratio to form chemical compounds. That means whenever the compounds are formed, they combine together in some simple whole number ratio. Next is in chemical reaction, atoms are combined, separated or rearranged, but never change into atoms of another element. Okay, that means in a chemical reaction only rearrangement of atoms takes place. However, the atoms cannot be formed or it cannot vanish on its own. That means whatever the atoms are on the left hand side of the reaction, the same number of atoms and the same type of atoms will be on the right hand side also. The atoms cannot change its form. One atom cannot become another atom of another element. Now let us quickly recap how to find out the molecular mass. We have taken an example of washing soda. The formula is Na2CO3.10H2O. This was there in grade 10th also. Now we'll find out the molecular mass of this compound. Now since we know that molecular mass is the sum of the atomic masses, that means we have to find out the sum of the atomic masses of all the elements which are present in the given molecule. Now the molecular mass is equal to 2 into 23, 2 atoms of sodium, and the atomic mass of sodium is 23, plus 12 into 1, that is 1 is the number of carbon atom and 12 is its atomic mass, plus 3 into atomic mass of oxygen, which is 16, so 3 into 16, plus 10 H2O, 2 into 1, that is the number of hydrogen and its molecular mass, plus atomic mass, not molecular mass, atomic mass, plus 16, that is the atomic mass of oxygen. Now we will multiply these number and then we'll add up all the products together. Now 2 into 23 is 46, 12 plus 3 into 16 is 48, plus 10 into 18 is 180. The sum of all these term is equal to 286 AMU. That means the molecular mass of washing soda is 286 AMU, atomic mass unit, or U, which is your unified mass. Now this molecular mass becomes important when we carry out the mole concept. Please understand how to find out the molecular masses. Molar mass. First of all, we'll discuss what is a mole. Okay? Now, when we talk about the atoms and molecules, they are extremely small, and even if we take a very small amount of such a substance, the number is very, very large. And to deal with such numbers, we need a unit which have got similar magnitude. Just as we denote 1 dozen for 12 items, score for 20 items, similarly, we use the idea of mole to count the entities at microscopic level. That is, the atoms, molecules, ions, electron, etc. And in SI system, mole was introduced as a 7 base quantity for the amount of the substance. And how do we define this 1 mole? 1 mole is the amount of a substance that contains as many particles or entities as there are the atoms in exactly 12 gram of carbon 12 isotope. That means if we take 12 gram of carbon 12 atom and start counting the number of atoms, if we have any substance which is equal to the number of atoms which are present in 12 gram of carbon 12, then that number is called 1 mole. Now that we have defined 1 mole, it must be kept in mind that 1 mole of a substance, if we take, it always contains the same number of entities, no matter what the substance may be. But the question is how to find out the number of particles in 1 mole. This can be found out if we can have the mass of 1 atom of carbon 12, and if we divide 12 gram with the mass of 1 atom of carbon 12, then we can easily find out the number of particles that will be present in 12 gram of carbon 12 atom. And by mass spectrometer, the weight of 1 atom of carbon is found out, and it is equal to 1.992648 into 10 inverse 23 gram. Now dividing 12 gram with this figure, we get 1 mole. That means 1 mole is equal to 12 gram divided by 1.992648 into 10 inverse 23 gram, and the figure that we get is equal to 6.022 into 10 power 23 atoms per mole, and this is equal to Na. This quantity is equated with Na, okay, and Na is in honor of Amedeo Avogadro, and this is called the Avogadro number or the Avogadro constant. It's a huge number, in fact. So if I take 1 mole of hydrogen atom, then this is equal to 6.022 into 10 power 23 atoms. Similarly, if I take 1 mole of H2O molecule, then this will also be equal to 6.022 into 10 power 23 molecules. and so on. In fact, if I take 1 mole of electron, then this will also be equal to 6.022 into 10 power 23, or this is equal to the Avogadro number of particles. Now that we have understood mole, we can find out the mass of 1 mole of substance or 1 mole of particle. How do you define molar mass? The mass of 1 mole of a substance in gram is called its molar mass. And the molar mass is always numerically equal to the atomic, molecular or formular mass in gram. For example, molar mass of water is 18.02. It is because the molecular mass of water is 18.02. That is the sum of the atomic mass. And if we take mass in gram numerically equal to its molecular mass, then we get the molar mass. So molar mass of water is 18.02 gram. And similarly, the molar mass of sodium chloride is equal to 58.5 gram. Now let us try to understand the difference between the term atomic mass, molecular mass and molar mass. Atomic mass is simply the mass of one atom. If I take sodium, the atomic mass is 23. If I take carbon, the atomic mass is 12U. If I take nitrogen, the atomic mass is 14U. And then the molecular mass is the mass of one molecule. For example, I have H2O here written. That means the sum of the atomic mass is equal to molecular mass. So molecular mass is basically the mass of one molecule. Now, next is your molar mass. Molar mass is mass of 1 mole particle. If we take 1 mole of any particle, then its mass will be equal to molar mass. That means molar mass is mass of 6.022 into 10 power 23 particles. Thus we have atomic mass or molecular mass is the mass of either one atom or one molecule of a substance. Whereas molar mass is the mass of 6.022 into 10 power 23 particles. Now, these many particles can be either atom or molecules. If I take the mass of 6.022 into 10 power 23 atoms in gram, then it becomes gram atomic mass, and we write it as GAM. And similarly, if we take 6.022 into 10 power 23 particles or molecules, then the mass of this one in gram will be equal to gram molecular mass, and we denote it by GMM, gram molecular mass. Let us take an example of oxygen. We at times write the oxygen as 16U and sometime as 16G. What is the difference between these two? When we write the oxygen as 16U, then we are talking about the atomic mass, that is mass of one atom of oxygen. And when we write it as 16G, then we are talking about mass of 1 mole of oxygen atoms, and this is equal to 16 gram, and it is called your gram atomic mass. Now it is necessary to make a difference or distinction between these two whenever we are solving the numericals. Similarly, when we are writing 17U and 17 gram for ammonia, then 17U is the molecular mass, that is sum of the atomic masses, and 17 gram is the mass of 1 mole of ammonia molecule in gram, that is called gram atomic mass. Thus 1 mole means, in case of atoms, if we take 1 mole of atom, then it is equal to 6.022 into 10 power 23 atoms, and this is equal to gram atomic mass. For molecules, if we take 1 mole, then it is equal to 6.022 into 10 power 23 molecules, and the weight of this one in gram is equal to gram molecular mass. Now, if we take gases, then 1 mole of any gases is equal to 6.022 into 10 power 23 particles, and this is equal to 22.4 liters under the normal condition of temperature and pressure, is called the molar volume. And if we take any of the gases, the molar volume under the standard conditions always remains same. Whether we take hydrogen, whether we take oxygen, whether we take carbon dioxide, sulfur dioxide, or any other gas. If we take 1 mole of these gases, then their volume is always equal to 22.4 liters. Since the volume of gases changes on changing the temperature and pressure, so 1 mole of any gas is equal to 22.4 liters at STP only. And at STP, the pressure is 1 atmosphere and temperature is 273 Kelvin. Now let us try to understand the formula which will help you to solve the numerical based on mole concept. There are 4 basic formula that you need to understand. First one is, if the mass of the atomic substance is given, then you can find out the number of mole as given mass upon the gram atomic mass. That means number of mole is equal to the mass of the substance which is given, and it has to be divided by the gram atomic mass. This will give you the number of moles. If the molecular mass of the substance is given, then the number of mole for molecular substance is equal to the mass of the given substance upon the gram molar mass. This will give you the number of mole of the molecular substance. For gases, number of mole equal to volume of the gas in STP condition divided by 22.4 liters. This will give you the number of moles. And for the number of particles, if the number of particles are given, in that case the number of mole is equal to the given number of particle upon the Avogadro number. That is, the given number of particles is divided by 6.022 into 10 power 23 particles, and this will give you the number of moles. You need to remember these formula to solve all the questions based on the mole concept. In fact, these formulas can also be derived by a simple unitary method also. Now let us try to understand the interrelationship between these different quantities. Let us first discuss the relationship between the mole of substance and mass of the sample. If we multiply the mole of the substance by molar mass, we get the mass of the sample. And if we divide the mass of the sample by the molar mass of the substance, then we get the mole of the substance. That is, mass upon molar mass equal to number of mole. Okay. Next is your mole into molar mass equal to mass of sample. Now toward right, we have relationship between mole of substance and number of molecule. If the mole of the substance is multiplied to Avogadro number, then we get the number of molecules. And if the number of molecule is divided by the Avogadro number, then we get mole of the substance back. Similarly, the relationship between mole of element and mass of element. If the mole of the element is multiplied to the elemental molar mass, we get the mass of element. And if the mass of the element is divided by the molar mass, we get the mole of each element. Similarly, if we multiply the moles of each element by Avogadro number, we get the number of atom of each element. And if the number of atom of each element is divided by Avogadro number, we get mole of each element. You should know this interrelationship to find out the quantities which are asked in the mole concept. So today we have learned a very important concept of chemistry, the mole concept. Remember that the mole concept becomes very important when we solve the further numericals based on the concentration, the empirical formula, the stoichiometric relations. All of them will require the knowledge of mole concept. Please learn all this formula very clearly, although we may make use of the unitary method to find out the interrelationship between these different terms which are used in the mole concept. But still, if you remember the mole concept formula, then it becomes easier, or you can quickly solve the numericals. So this was all that we had for today. Tomorrow we will make use of this mole concept to solve some numericals. Till then, please learn the formula, clear your concepts, so that we can make use of these concepts, these formula, to find out the numerics, or to derive the numerical, to solve the numericals. Thank you very much, students.